Hello, today in this video, we will be discussing a few types of heat treatment and the steps involved in each process. Heat treatment is a controlled process used to alter the physical characteristics of metals and alloys. Heat treatment is at the heart of industrial technology. This technology has provided many processes to modify the physical and chemical characteristics of many metals used today. These various processes and techniques allow us to manipulate properties such as strength, hardness, toughness, and elasticity. The heat treatment processes that we will discuss in this video include cold working, annealing, quenching, and tempering. To begin, cold work is the process of strengthening metal by altering its shape without the use of heat. Cold work is better known as the plastic deformation below the recrystallization temperature of a metal and can be classified as squeezing, bending, shearing, and drawing. The cold working process reduces the ability of crystals to move within the structure, resulting in a material that is resistant to further deformation. Some advantages to cold working over other processes is no need for heat, exceptional dimensional control, better reproducibility and interchangeability, and the chance of contamination is minimized. While there are many advantages, some disadvantages include the need for harder tools and dies to work the material, a loss in ductility and malleability, and may leave undesired residual stress in the material. An example of cold working would be compressing metal to form propane tanks. Here we can see a round disc that is compressed into a bowl shape to form one half of a propane tank. The next type of heat treatment involves annealing. The annealing process involves heating a metal to a specific temperature and cooling at a rate that will produce a refined microstructure. Typically, annealing is a process used to soften a metal that has been previously cold worked to improve machinability as well as reduce stress and improve ductility and malleability. During the process of recrystallization, annealing, new grains are formed which have a reduced number of dislocations compared to the previously cold worked metal, returning it to its pre-cold work state. Time also plays a key role in the annealing process. The longer you tend to anneal a metal, the more the hardness tends to decrease. I have included a picture to illustrate the different grain structures at different temperatures for the annealing process. The third heat treatment process we will discuss involves quenching. Quenching is the process of rapidly cooling a metal from a high temperature to a low temperature at a rapid rate. For the process to occur, the metal must be heated above its critical temperature and cooled in either oil, water, or a brine. This process results in austenite transforming to martensite, a very hard and brittle material. However, if the quenching process is done too quickly, there is a possibility of bending or cracking your specimen. Here you can see I included a few examples, one being someone quenching a knife and the other quenching a horseshoe. Finally, the last heat treatment process we will discuss is tempering. While quenching results in a material that is very hard and brittle, most of the time the material must be tempered to alleviate this problem. Tempering involves heating a material right below the lower critical temperature, ranging anywhere from 400 to 1100 degrees Fahrenheit. This process is used to negate some of the hardness and brittleness caused by quenching, as well as relieve some residual stress formed along the process. Once tempered, the material will have the appropriate hardness, brittleness, and ductility, resulting in a material that will be tougher overall. Here we can see an image of tempered martensite at its initial stage, followed by 2 hours at 1209 degrees Fahrenheit and 12 hours at 1209 degrees Fahrenheit. As you can see, the martensite begins at a high dislocation density, followed by low dislocation density, and finally, recrystallization is visible in the first example. Finally, I have included a few sample pictures of various components, such as ring gears and crankshafts, undergoing a form of heat treatment. Thank you for watching, and I hope you enjoyed this video covering various heat treatment processes.